In 6.4, we're introduced to logarithmic functions. The log function is the inverse of the exponential function, so that's why we study these together. The definition of the log function was given. It says that y is equal to log base A. A is a base, just like right here, A is a base. We say that's the base of the exponent. Well, it's the base of the log. It's a subscript, a tiny little number there. Log base A of x. So y is equal to the log base A of x, and this kind of if and only if, this is also true. A to the y is equal to x. So that's also true the other way. That's why I've drawn this arrow going both ways. If this is true, then this is true either way. So notice if our y is in the same spot here, in other words, a log is just an exponent. All of this is equal to y, and y is an exponent. So logs are just exponents. Okay? The domain of our log functions is x is greater than 0. X has to be a positive number. So some of the things you'll do in this section, you'll start by converting back and forth between these two forms. So let's practice that first. I'm going to rewrite it here. You should be able to write this. I'll just do that. You really need to have that just flat out memorized because you'll have to convert back and forth many, many times in Chapter 6. So we might have a problem that says log, here's our first one, log base 3 of 81 equals x. And our instructions are just to change it from a log to an exponential. Now, it's switched around a little bit, you know, on the either side of the equal sign, but I can still tell what's what here. So to change this, I'm going to write a. So what's my base? A is the base. The base of this log is 3. So rewriting this would be 3, 3 is my base. 3 to the, here I've written it as an x, right? I can change the variable. Here it's a y, but what we're equal to is x. So 3 to what power? 3 to the x power is equal to, and then it says just whatever x was. Well, x was this 81. I'm taking the log base 3 of 81. 3 to the x equals 81. And now we have an exponential. And we know how to solve this one because if we were asked to solve it, we just continue and write 81 as a base of 3. With a base of 3, it's actually 3 to the 4th, and we'd find that x is equal to 4. But this one just says change from a log to an exponential, and here's an example of change from an exponential into a log. A to the y equals x. Y, so what's y in this one? Y is the exponent. X equals log base A. What's my base? It's e. Log base A of x. X is here, of 6. Now I'm going to take a minute now to point something out. I've written this log base e, but that one occurs so often, and it occurs in nature, that e occurs in nature so much that we call log base e of x, we rewrite that. We never write it like that. It's ln e with no little subscript, and this is called the natural log. It's a special one. When it's base e, we don't write it like that. We write ln. Look on your calculator, and you're going to see two special logs. You're going to see ln, and that's the natural log. That means it has a base of e. So I would come back here and write this as x equals natural log of 6, and you could actually calculate that on your calculator because you have this button. You type in 6, you'll get an irrational number. This would be the exact answer. Your irrational rounded would be an approximation. So this is our natural log. There's one other one on your calculator. It just says log, and what that is base 10. So we just write log x, and when you see that, you know it's base 10. Sorry, the base is always 10. Right, we're not getting that. Here we go. So when you see log with no subscript whatsoever, that doesn't mean there's not one. It means we understand it to be base 10. Like we do with square root. You don't see a 2 there for the index. We've all agreed if there's nothing there, it's square root. Otherwise, there'll be a 3 for cube root or a 4 for fourth root. Likewise here, if it's just logx, you know there's a subscript of 10 there that's just understood. If we see ln e, we know the subscript is e. Oh, sorry, look what I did. This should be an x. Please fix this. This should be lnx. lnx. Talking and writing is sometimes difficult. Okay, so lnx, not lne. E is the base that's not, we don't see there because it's understood when you see ln. Okay, so please fix your notes. Log base e of x is the same as lnx. That's the natural log. These are the two on your calculator. So if you have something like log base 3, that's not on your calculator. You can't just punch that in. You don't have that. You have base 10, you have base e, that's it. We will learn how to calculate this, but right now we haven't done that part yet. So it's not a direct calculation on your calculator. Okay, so these are some things we would do in 6.4, write from log to exponent, from exponent to log to get practice of understanding this, which you absolutely must know. And then the other thing is the domain of a log function. So remember we said f of x equals log base a of x, or in other words, y equals log. We can write it either way for a log function, right? F of x and y are the same thing. And we said our x is greater than 0 for our domain. So what if we're asked to find the domain of f of x equals the log of x plus 4. Okay, what's the domain? In other words, what values can x be? Well, here's how we figure that out. We say, well, x plus 4 must be greater than 0 because that's what we're taking the log of, x plus 4. So if we plug in an x, we must get a number that's greater than 0. So x must be greater than negative 4. So our domain is values greater than negative 4. In interval notation, negative 4 not including, so parentheses, to infinity. And in set notation, the set of all x, such that x is greater than negative 4. Okay? So whatever is here, set greater than 0 and figure out what those values must be for your domain. Okay, that concludes here. We'll work a few log equations in the next video.